Hi, so for today we're going to continue our discussion all about evaluating the Laplace transform by using the table of Laplace transform. This is already the part 2 of our discussion about evaluating Laplace transform by tables. So if you haven't watched my part 1, okay, part 1 lecture, video lecture all about Laplace transform, please see it first and please watch it first before watching or proceeding in this video. But if you are done with that, then well done. We shall be continuing our Laplace transform by table form. Okay, so for example, we have an f of t that is in this form. Okay, it has an exponential function multiplied by a trigonometric function. Let's say e raised to at, where a and b are any constants. Again, we have to transform this into Laplace transform. We need to find the Laplace transform of this f of s. So we will be having this b over quantity s minus a squared plus b squared. Okay, and that is the Laplace transform for this certain function. And again, of course, if the sign is changed by cosine, the Laplace transform also will be changed. But the change would be is that this would become s minus a over quantity s minus a squared plus b squared. Pretty much the same for the Laplace transform of sine and cosine, but the difference is that there is a minus a, s minus a on the denominator because of this exponential function. And as you can see here, the same also for sine bt because it has a it's if we're going to evaluate the Laplace transform of sine bt alone, for example, that would be b over s squared plus b squared. So the same for cosine, we have s here. So happen that in evaluating this trig function cosine, we would be having only s here. But since this is now multiplied to an exponential function e raised to at, we have now s minus a over s minus quantity s minus a squared plus b squared. And last, for our formula, no, this is not the complete table for Laplace. That's why we have video lecture part 1, part 2, part 3. So we will be tackling almost all of the almost all of the formulas in the Laplace transform table. So for this one, we have t raised to n, where n is a positive integer, and then multiplied by a certain f of t. This f of t can be a trigonometric function or a hyperbolic function. As long as it's f of t, its Laplace transform is given by negative 1 raised to n, whatever the value of n here, and multiplied by the this is the f, okay, raised to n. This is actually the derivative. Okay, if the exponent of this is 1 multiplied by a certain function f of t, then we need to find the substitute 1 here. So this is negative 1, and f1 of s, it means the first derivative of that f of t. Okay, so later on we will be appreciating this. We would appreciate these tables if we are going to solve some problems. So let's try to solve some problems. For number 1, we have this problem wherein we have a given find the Laplace transform of e raised to 2t multiplied by sine 3t. Again, this is pretty much easy because we already have a Laplace transform table for this. So it says for sine, we need to get the b. In this case, this is our b, the number 3, and this is our a, okay, the 2. So if we're going to plug in this in our formula here, so we have 3 over s minus 2 squared plus we have 3 squared, and that corresponds to 3 over quantity s minus 2 squared plus 9. And this should be our answer for the first problem. How about for the second problem? Second problem is again easy also because this is a very straightforward problem wherein we have already this type of function. If we're going to get the Laplace transform, then definitely this is cosine 60. So we have For this, we have s minus 5, which is our value of a. Well, of course, if this is negative, this should become plus 5. But since this is a positive, so it should stay at as it is, minus sign, okay, for the formula. So, s minus 5 over quantity s minus 5 squared plus, again, 6 squared because this is our value of b, 6. So, we have s minus 5 over s minus 5 squared plus 36. 6 squared is 36. Okay? So, let's try again to solve some problems. Okay? Let's recall our discussion on the first part of our video wherein we're going to find the Laplace transform of the following. Okay? So, we are to find the Laplace transform of this. As we can see, we can distribute the Laplace operation here. Okay, wherein we can rewrite this as this, so we can evaluate each term individually to obtain the Laplace transform. Okay, we know that we can actually factor out 6 or the constant outside of the Laplace transform. Okay, and copy this again. And we can, this is simply 9 Laplace transform of 1. Okay. So again, if we evaluate this, this should be 6. From our previous discussion, for exponential, that is 1 over s minus a. But we have a negative here, so that would be s minus negative 5. Our a here is negative 5 plus the Laplace transform of this, that is 1 over s minus 3. Okay, plus we have a t raised to certain number exponent, positive exponent, t cubed. So we have to get the, again, the factorial, 3 factorial of our n divided by s raised to 3 plus 1. Okay, that's our formula. Minus 9, the Laplace transform of 1 is 1 over s. So simplifying, our answer, we have 6 over s plus 5 plus 1 over s minus t plus 3 factorial, that is 1 times 2 times 3 is 6 over s raised to 4 minus 9 over s. So this should be our Laplace transform for the given problem. This is our final answer. Okay, let's proceed with another problem. So for another problem, we have the Laplace transform of 4 cosine 40. Okay, minus 9 sine 40. Okay, plus 2 cosine 10t. 10t. Okay, so again, I can factor out outside of the Laplace operation the constant. So we have cosine 40 here. Minus 9 Laplace transform of sine 40. Plus 2, the Laplace transform of cosine 10t. Okay? So, what will happen here is, you have to get the Laplace transform of cosine 40, and we know that that is s over s squared plus 4 squared. Okay? Minus 9. This is sine, so we have to get the a, 4 over s squared plus 4 squared. Plus, this is again cosine, the Laplace transform of cosine, that is s over s squared plus 10 squared. So, simplifying, we have 4s over s squared plus 16 minus 9 times 3 is 36 over s squared plus 16 plus 2s over s squared plus 100. And since this has the same denominator, this two term has the same denominator, we can rewrite this as 4s minus 36 over s squared plus 16 plus 2s over s squared plus 100. And this should be our final answer for this problem. For number 5, okay? For number 5, let us find the Laplace transform of the hyperbolic sine 2t plus sine of 2t. Okay? So, hyperbolic sine and sine as different Laplace transform. Okay? So, I think the given is actually this. Okay? So, it's pretty easy. Why? Because if you evaluate this, this is in the table of Laplace transform. And for sine, we have 2 over s squared minus 2 squared plus for our sine, we have 2 over, because that is our a, s squared plus, okay? That's the difference between a hyperbolic sine and a normal trigonometric function sine. The denominator of the, for hyperbolic sine, it should be negative or minus. I'm sorry. And for the sine, that is positive. So we have 2 over s squared minus 4 plus 2 over s squared plus 4. Okay? And that should be our final answer for this problem. Okay, for number 6, let's try to solve this. We have the Laplace transform. Okay, we have the Laplace transform of e raised to 3t plus cosine of 6t minus e raised to 3t cosine of 6t. Okay? So, we have to evaluate individually the Laplace transform of this. Minus the Laplace, oops, I'm sorry, let me just rewrite this. Minus Laplace transform of e raised to 3t cosine 6t. Okay, and again, this is pretty easy. That is 1 over s minus 3. Plus, we have a cosine here. So, if cosine, that is s over s squared. Okay, plus 6 squared. Minus, this is the product of an exponential function and a trigonometric function. So, our a here is 3. Our b here is 6. That is 6. So we have this, since this is a cosine, so this should be s minus 3 over quantity s minus 3 squared plus b squared, which is 6, according to our table a while ago. So we have 1 over s minus 3 plus s over s squared plus 6, or 36, I mean. 6 squared is 36 plus 36 minus s minus 3 over s minus 3 squared plus 36. So this should be our answer for this problem of finding the Laplace transform for this number. Okay, let's try another one. Let's make use of the last formula that I've given. So let's try to find the what number it is. Is it it is 7. Number 7. So we have to find the Laplace transform of t hyperbolic cosine of 3t. Okay. As you can see here, this is t multiplied by any f of t. Okay, which is turns out to be a hyperbolic function. So this would be our f of t. This is our, simply our t. And our formula a while ago, if we have t raised to n multiplied by some f of t, where n is a positive integer number, its Laplace transform is given by negative 1 raised to n f of raised to n of s, which means this number of n in our Laplace transform is denotes the derivative. Okay? So if we're going to apply this, we know that from our given, our n is 1 because t is raised to 1. So, again, for this problem, this should be negative 1 raised to 1 f raised to 1 of s. Okay? So, what are we going to do here is if we evaluate this, this should be negative 1. And the first derivative, okay, f1 of s. So, our goal is first to find the f of s. Okay? Our f of s is actually, we're going to find, I'm sorry, let me just delete this. We're going to find the f of s of this f of t first. Okay? So if we get that, what will happen? If we get this, cosine 3t, okay, hyperbolic cosine of 3t, that is actually what? That is s over s squared minus 3 squared. So that would be s over s squared minus 9. Now, we are successful in getting the f of s of this f of t. What happens next is that, as I have said a while ago, the exponent of t here denotes how many times do we have to differentiate that f of s. So if we get the f prime of s, okay, because that is our goal. This is f prime of s, okay? It denotes the derivative, okay? It's, I'm sorry, this should be only this, okay, prime. Okay, if the n is 2, that is double prime. Okay, so this denotes a derivative, so we have to get the f prime of s, of which this is our f of s. So this is a quotient rule, so we have to differentiate. We have first to copy denominator, low d high. This is the low. Okay, derivative of high with respect to s, that is 1. Minus high, copy the numerator, and differentiate the denominator with respect to s, that is 2s, over, this is low d high minus high d low over low squared, s squared minus 9 squared. So that's how we get the derivative. Okay, so simplifying, we have s squared minus 9 minus, this should be 2s times s is 2s squared over, we have s squared minus 9 squared. So s squared minus s squared is negative s squared minus 9 over, okay, we have s squared minus 9 squared. Let us take note that what we get here, what is this, is the f prime of s. As we can see, our formula to be used to get our Laplace transform for this example, f prime of s, this is f prime of s, and we should multiply this f prime of s by negative 1 so that our final answer, it should be negated. Okay, so we have to apply negative sign, negative s squared minus 9 over s minus 9, quantity s minus 9 squared. So again, this negative is because of this formula. Okay, it's because of this term, negative 1, our n is 1. So this whole term should be multiplied by negative 1. So our answer, negative f prime of s, should be s squared plus 9 over s, quantity s minus 9 squared. So this is the Laplace transform for our problem here. So let's move on to the final problem for this video. Okay, so what number is it? 7. So we have number 8, last problem for this video. We need to find the Laplace transform of t squared the sine to t. Okay, again, this is again a function of t raised to a certain positive integer n multiplied by a trigonometric function sine 2t. So this is our f of t. So this is our t raised to n. So if we apply the formula again, negative 1 raised to n, okay, of f of the nth derivative of f of s should be equal to t raised to n, okay, f of t. So where n is equals to 1, 2, 3, positive integer. Okay. So this has the form of this. So the Laplace transform is this. So first, let us evaluate. Our n for this problem is 2. So if we are going to substitute it to our formula here, so we have negative 1 squared f of the second derivative of s. So therefore, negative 1 squared is equal only to 1. So we have the second derivative of s, or f double prime of s. So simply, we should get the double prime of the f of s. Of which, again, this should be our f of s. If we are to transform this should be our f of s. So again, let's first get the transform of that f of s of our f of t. So our f of t is sine 2t. Then therefore, the Laplace transform of that by table is, again, since that is a sine, so that must be 2 over s squared plus a 2 squared. And that is 2 over s squared plus 4. Okay? So that is not the final answer. That is our f of s. We need to find f prime of s. So we need to differentiate this. So low d high. So copy the denominator, s squared plus 4. Derivative of high with respect to s, that is 0 because that is a constant, minus high derivative, high, copy the high. Okay? The high term or the numerator, high the low. So derivative of the denominator, that is 2s. Okay? Over, we have s squared plus 4 squared, and we know that this term should be 0. So upon simplifying, we have negative 4s over s squared plus 4 squared. And what we get here is only f prime of s. So in order for us to get the final answer for this, we need f double prime s. So we need to differentiate this once again. So upon differentiating, we need to copy the denominator. Low d high, differentiate the numerator, that is 4, negative 4, minus high, copy the numerator, negative 4, along with its sign, and differentiate the denominator. So that would be 2 multiplied by s squared plus 4 times 2s. We use chain rule here. Okay? Oops, we use the chain rule. I hope you can still see. Over s squared plus 4. Okay, this is squared again. If we square this, that becomes 4. The what do I call this? The exponent. Okay, so we have to square this. So this becomes, okay, negative 4. Let's try not to distribute it first. Okay, so this would become negative 4s times 2, negative 8s times 2s. Negative 8s times 2s is negative 16s squared. Okay, negative 16s squared, and then we have a minus sign here. So that becomes positive 16s squared multiplied by s squared plus 4. Okay, over, again, s squared plus 4 raised to 4. And let me just rewrite this on the other side of other page. Okay, so upon rewriting here, I can rewrite this as negative 4s squared. Okay, let me just rewrite first. So that would be negative 4 s squared plus, is it a plus? S squared plus 4 squared, okay, plus 16s squared, and s squared plus 4, I hope that's correct, and over s squared plus 4 raised to 4. Let's see. Okay, 16s squared. Okay, that's correct. Okay, as you can see here in the numerator, we can factor out s squared. So this term has common s squared plus 4. So we have s squared plus 4. We can factor that out. So this would be negative 4 times s squared plus 4. So this would be plus 16s squared. And as you can see here, over S squared plus 4 raised to 4. So this would cancel. S squared plus 4. So this becomes cube. Okay. And what will happen here? We have negative 4 s squared plus 4 plus 16s squared over s squared plus 4 raised to 3. Upon simplifying, we have to distribute negative 4. That becomes negative 4s squared minus 16 plus 16s squared over s squared plus 4 raised to 3. As you can see, negative 4s squared plus 16s squared, that becomes 12s squared minus 16 over s squared plus 4 raised to 3. And that should be our final answer for this problem. Guys, I hope you learned something for today's lecture. This is again Engineer Abat. Thank you so much for listening.